All right, today is HA2. It's more with imaginary numbers, also called complex numbers. Today we're doing operations with complex numbers. So operations, you think your basic 4 operations are add, subtract, multiply, divide. So that's kind of what we're going to be working on today. So it says, form addition of complex numbers as you would for the addition of binomials of the form a plus bx. To add such binomials, you collect the terms. So don't overthink this. Let's take a look at what's written here. That's not anything new. That's not imaginary numbers. Those are x's. If I were to combine the 5 and the -2, those are like terms. I get 3. And if I add the 4x with the 3x, that gives me 7x. Okay, it's not much different over here with complex numbers. I have a 5 and a -2. That makes 3. I have a 4i and a 3i, which makes 7i. So adding is very similar. So go ahead and pause the video and try A, B, and C. So to go through this, my constant terms are 10, or my real numbers, and then my imaginary numbers are 5i and -7i, so -2i. The next one is -8 plus 2i. Of course, we don't combine those together. We don't make it -6i. We leave them separate. 2 and -2 is 0. 3i and -3i is 0, so that's just 0. So we're going to skip over that part and look at number 2. Now it says find the sum or difference. We've only done the sum or the addition so far, but let's look at the difference real quick. Let's do A together. Notice we're subtracting all of this. We're not just subtracting the -5. So the only real difference between adding and subtracting is if you're subtracting and you're subtracting more than one thing, it's going to be in parentheses. You'll subtract both. So I might just rewrite this one. Distribute the negative, so that'd be a +5 and a -4i. Then I combine my like terms like usual. So that would be 17 minus 17i. The next one you're adding, so it's like distributing a positive one. So you don't really have to do that because it's not going to change anything. So I have a half and 5 halves. 1/2 and 5 halves is 6 halves, and 6 halves is 3. Try to do that without a calculator, just for mental math practice. And then I have plus 8i. Okay. My like terms are 2 and √2. Now I can't really put them together. I wouldn't put 2 √2 because that's multiplying. So there's not a good way to put those together. You just are going to write 2 plus √2. And then those also aren't really alike either. They both have an imaginary part. But you can't combine it if one has a root and one doesn't. So I'm just going to write them grouped together. So this and this group together first, and then the imaginary parts next. And then what you can do is you can factor out an I. So if I factor out an I from this term, I would get -7. Factor out an I from this term, I get √3. So not a great way to do that one. And then the last one, you'll notice you're adding and subtracting here. So I'm just going to copy the first one. Distribute the negative. And then this is distributing a positive, which doesn't change anything. My numerical terms without I, my real parts are 8, -3, and -5, which makes 0. And then -5i, -5i, and +10i makes 0i, which is 0. Make sure you simplify it to 0. Okay, so we've just done adding and subtracting, and now we're going to jump to multiplying. So you can look over example B there on page 127 if you want, but we're going to go ahead and do some together. So multiplying, just like regular multiplication, let's go ahead and distribute the 6. 6 times 4, 24. 6 times negative 7i is negative 42i. 5i times 4 is 20i. 5i times negative 7, negative 35i squared. Notice it was I times I. So that shouldn't be really anything different. Distribute the 6, distribute the 5i. Now we are going to simplify here. So negative 42i and 20i is negative 22i. And here's something new that we haven't worked on yet, but I want to introduce this. I squared. Think about I. So this is I. And what happens when I take I and I square it? When I square this, I get negative 1. So somewhere in your notes, make a large note, I guess, about this off to the side, that I is the square root of negative 1, but I squared is negative 1. Here's how that's helpful. Because if you look here, I have I squared. So that's negative 1. So that's negative 35 times negative 1, which is actually positive 35. So I have 24 minus 22i plus 35. And now I don't have an imaginary part here. I can just add the 35 with the 24 and get 59 minus 22i. Okay, let's practice another one. Part B, distribute the 2. Distribute the negative 3i. Check your work. Let's combine our i's. So I have 6 minus 13i. And remember, I squared is negative 1. So that's 6 times negative 1, which is negative 6. Now 6 and negative 6 give me 0, so I just end up with negative 13i. Okay, why don't you try the last one? Pause the video. Okay, here we go. So this is going to be 25 plus 5i plus 5i plus I squared, which is 25 plus 10i minus 1. So 24 plus 10i. And again, don't combine those, leave them the way they are. Okay, so multiplying should make sense now. I do want to go back up to this note that you have somewhere off to the side. This here, we're going to add 2 things to it. So we know I is the square root of negative 1. We just learned that I squared is negative 1. But what about I cubed? Well, let's think about this off to the side. Isn't I cubed the same as I times I squared? Right? So what's I? Square root of negative 1. And what's I squared? Negative 1. So when I multiply those together, I get negative root negative 1, which is negative I. Pause the video, go back through that if you need to for it to make sense. So I cubed is negative I. And the last one we're going to do is I to the 4th. So let me erase some of this. Isn't I to the 4th the same as I squared times I squared? And what is I squared? It's negative 1. That's what this says right here. So negative 1 times negative 1 is 1. So what's really cool is if I have an imaginary number and I have that to the 4th power, I actually get a real number, the number 1, which is pretty cool. All right, let's flip the page and go to division. There's actually some more for you to practice, but to make the video a little shorter, I'm going to skip over those since we've kind of done an overview already. And we're going to go to above number 12, page 129. The complex conjugate, so that's a new term, of a plus bi is defined as a minus bi. For example, the complex conjugate of 2 plus 3i is 2 minus 3i. Very simple. The real part stays the same. The imaginary part becomes the opposite. Number 12, a special property of multiplication of complex numbers occurs when a number is multiplied by its conjugate. Multiply each number by its conjugate, and then describe the product when a number is multiplied by its conjugate. So we have 2 minus 9i. We're going to multiply that by its complex conjugate, which would be 2 plus 9i. Let's see what we get when we multiply a number times its complex conjugate. 4 plus 18i minus 18i minus 81i squared. 18i and negative 18i is 0 i's, so that cancels. And then I squared is negative 1. So I have negative 81 times negative 1, which is positive 81. So I get 85. So what happens when I multiply a number by its complex conjugate, you're always going to get these I parts to cancel. You're always going to get I squared. And so you'll just have a real number. You won't have an imaginary part to it. Okay, this is going to come into play when we do the next section, 8.3. Let's try another one. Maybe pause the video, try it on your own. I want to multiply this number, I'll do it over here, by its complex conjugate. So what is its complex conjugate? The first part stays the same, negative 5. The imaginary part changes signs. Okay, let's distribute that out. And then when I simplify, 10i and negative 10i cancel. I squared is negative 1. A negative 4 and a negative 1 is positive 4. I get 29. Again, I get one number. There's no i's in there. So, write an expression to complete the general form of the product of a complex number and its complex conjugate. So think about this. Here's a number, and here's its complex conjugate. What is going to happen there? Now, you might be able to figure it out based off of the pattern that we did above, but let's go ahead and distribute it out and look at what happens. So we have a squared minus abi plus abi minus b squared I squared. Now, if you're confused on these, you could write them in any order. So when I multiply bi times a, if you're multiplying, you can put them in any order. I just preferred to write them in the same order that I had written the last one. Negative abi and positive abi will cancel. Even though I don't know what number that is, a positive and a negative are the same thing as going to cancel. So that leaves me with a squared. Don't forget I squared is negative 1. So that leaves me with negative b squared times negative 1, which is going to be a negative times a negative is positive. So it's going to be a squared plus b squared. Anytime you multiply something by its complex conjugate, you'll get a squared plus b squared. Let's look and see if that happened above here. If this is my a and this is my b, what is a squared? 25. What is b, which is the part without the imaginary, the 2? B squared is 4, which gives me 29. Let's look at the top one. We got 85. If A is the 2 and B is the negative 9, A squared is 4 plus B squared is 81, which gives me 85. So again, like I said, tomorrow this is going to come in handy. If you have a number multiplied by its complex conjugate, it's always going to give you a squared plus b squared. Okay, now finally, let's talk about division. There's an example C there on page 129, but we're going to skip over that. We're going to just start by doing sum together. So let's look at B on page 130. Now, before we start, here's a common problem I see students do, a common mistake. When they have division like this, let me give you a different problem. Just watch for a second. Let's say I have 6 over 6 plus 2. Here's what some people do. They write it as 6 over 6 plus 6 over 2. Is that correct or not? No, think about this original problem. This original problem is 6 over 8, which simplifies to 3/4, but it's definitely less than 1. When I change it to 6 divided by 6 and 6 divided by 2, that becomes 6 over 6 is 1, plus 6 over 2 is 3. It becomes 4. That is not the same thing. Now, the reason people do this is because the opposite is true. If I have 6 plus 2 over 6, then I can do 6 over 6 plus 2 over 6, but not the other way around. So if I have 2 things in the numerator and 1 in the denominator, both of those things are being divided by 6. It doesn't work the other way around. If I have a numerator and 2 parts in the denominator, you don't break them apart when there's addition like that. Okay, so going back to this, it's not 5i over 2 plus 5i over 3i. That will not work that way. So we need to talk about how to do this. So it says divide the complex numbers, write your answer on notebook paper. You might have to get some notebook paper now because it might take a bit of work. So here's how we divide, and it's explained for you on page 129 at the bottom, but I'm going to walk through it with you now so you don't have to look at it yourself. You can later if you want to. The way you divide is quite a bit different than how you add, subtract, or multiply. What you want to do is you want to multiply by the complex conjugate of the denominator. So the denominator is 2 plus 3i. Complex conjugate is 2 minus 3i. Now, if we do it to the top, we got to do it to the bottom to keep it still giving you the same problem. So step 1, multiply by the complex conjugate of the denominator. What will that do? Let's simplify the top. The top is going to be, should be the 5i, 10i minus 15i squared. We'll simplify that in a minute. And the denominator is going to be 4 minus 6i plus 6i. You probably thought that was going to happen because it was a complex conjugate, minus 9i squared. Let me keep moving this direction as I simplify. Let's look at the denominator. Negative 6i, positive 6i cancel. I squared is negative 1. So that is 4. Negative 9 times negative 1 is going to be plus 9. So my denominator is 13. Now, it looked like we complicated the problem way back up here. We had a nice simple fraction. We put a whole bunch more with it. But what happens when I multiply by the complex conjugate is I get a real number in my denominator. You have to have a real number in your denominator for your final answer. Now let's simplify the top. So I have 10i that can't be simplified. I squared is negative 1, negative 15, and negative 1 is positive 15. So I have 10i plus 15. This is my answer. Sometimes we prefer to write it as the real part and the imaginary part. So you might see it often written as 10 over 13i plus 15 over 13. That way the real part is separate from the imaginary part. But I would accept this answer also. Okay, so quite a bit of work. Let's try the next one. So step 1 is to multiply by the complex conjugate of the denominator. So that's going to be 3 plus 4i. And let me go ahead and simplify the top. So distribute 15 plus 20i plus 6i plus 8i squared. If you prefer to keep simplifying the top, you can. I'm going to go ahead and do the bottom. 9 minus 12i plus 12i minus 16i squared. So if I simplify the top to move forward, that's going to be 15 plus 26i. I squared is negative 1, so that's going to end up being minus 8. My denominator, negative 12i, positive 12i cancels. I squared again is negative 1, so that's going to end up being plus 16. My numerator is going to simplify to 7 plus 26i. My denominator is 25. And I'll probably write my answer as 7 over 25 plus 26i over 25. The I can be in the numerator or just off to the side. So I'd be read 7 25ths plus 26i over 25. All right, and the last one, part D. Let me slide all this over so we have a lot of room. Maybe it looks different because there's a root in the denominator. That's not a problem. We would still multiply by the complex conjugate. So the complex conjugate, the real part stays the same. The imaginary part changes sign. So that's root 3 minus 4i. Okay, let's go ahead and simplify the numerator. Distribute. 1 times root 3 is root 3. Negative 4i minus I root 3 plus 4i squared. Your denominator, root 3 times root 3, think about that off to the side. Root 3 times root 3 is root 9, which is just 3. Oops. That's going to be 3, minus 4i root 3 plus 4i root 3 minus 16i squared. Maybe you like working vertically. I'm going to do horizontally for this to simplify. So let's go ahead and simplify the top. This is going to be negative 1. So I have root 3. I can't really combine this I with this I because one has a root and one doesn't. So I'm just going to leave it for now. Minus 4i minus I root 3. And then this is going to be minus 4. My denominator, these will cancel. I'll get negative 1. So that's going to be 3 plus 16. My denominator then is 19. I'm going to put my real parts written by each other. So that's negative 4 plus root 3. And I'll put my i's written next to each other. Minus 4i minus I root 3. This way, when I write my final answer, I can put the real part here and the imaginary part here. You won't have a lot that looks this complicated, but that would be how you would do it. You could also, because this part has I in both, you could do this if you want. Oops. Keep the first part the same. Over here, you could just put an I at the end. probably how I would write my final answer. Okay, so division takes a little bit more time. Always start by multiplying by the complex conjugate. And now you've done adding, subtracting, multiplying, and dividing.